Hi, I'm Jacqueline Nolis. I'm a data scientist. I'm joined here today by Heather Nolis, a machine learning engineer from T-Mobile. And this talk is about how we did something we're so excited about, and it's how we got R working in R and production environments. So what does it mean to put something into production? And we heard about that a little bit already during the keynotes. But we think about it like this. With data science, there's like two types of data science. There's A-type analysis, where you're trying to figure out an idea, do an exploration, figure out something, and your deliverable is an idea. And then there's the building type, where you make a machine learning model, and you want to run it. You want to run it over and over, like if you're designing a product recommendation engine for a website. And so at T-Mobile, we really defined putting code into production as making it so that customers can interact with it. And this morning, we heard about making dashboards that many users can use at once, maybe 20. Well, we have 70 million customers. And we just merged with Sprint, who has another 60 million customers. So we have lots and lots of people. And when we're talking about machine learning, we're really talking about making machine learning models that all of those people can use. Hopefully not all at once, but all of them could use. And so the project was called AI at T-Mobile. So T-Mobile has been doing data science for many years, and we have lots of people who are very good at things like that exploration, building churn models on our customers, that sort of reporting work. But we didn't have very much of putting machine learning models that we developed into production environments so our customers can use them. So this project was to actually take machine learning and get it in front of our customers in a way that really improves the customer experience. And I say that because T-Mobile has a really big deal about being the uncarrier. So we're not going to make you have to go deal with chatbots and have bad experiences. We want things to be pleasant for our customers. So our first scope was customer care messaging. So right now, today, you can go on your phone and you can text T-Mobile. And you can say something like, I don't have, my coverage is bad. And a human being at a desk will respond back to you and help you try and diagnose your problem. And so we can do that through text message. We can do that through Facebook Messenger. You can slide into T-Mobile's DMs and send a message, and a human being will respond back to you, or use our in-app messaging. So we have all of this text data. We have all of this stuff that's ripe for natural language processing. And our objective was, let's get some machine learning around that makes things better for the customer. So our first particular use case was consider, our customers, they talk in all sorts of weird ways. So suppose we had one particular customer come to us and say, this high bill shall not pass, which is an utterance we had never seen before. And we have the goal of, we have an agent at a computer who's responding to these messages and maybe has like 8 conversations going on at once. We have the goal to try and prep them, that it'd be really helpful if that agent, when they started the conversation, already knew the status of the customer's bill. And so what is our method? Well, we're going to build a classification engine with machine learning. So in this case, this high bill shall not pass would be classified as a bill breakdown message. And then further, we can improve that by actually using customer data. So if we know something about this customer, like if we know their recent account activity, their current signal strength, their bill status, like maybe it's overdue, that may change what we want to show the agent. So you can imagine if a customer just got their account suspended, like 20 minutes ago, and they come to T-Mobile and they say, hi, well, we probably know what they're talking about. So we can use that data to help inform our machine learning prediction. So how do we create the models in R? Well, our workflow was like this. One, we would start by using R Markdown for exploratory analysis. So we would take those many conversations that we have between customers and agents, and we'd try and build an understanding of what happens in them. What are the things people kind of talk about? And then once we get a better idea, we would build a machine learning model in R, and then we'd save those models to flat files. And in particular, we would do the model building with R Markdown so that we could actually have a log of exactly how it was built, what data went in, how well the fit went, and then we save all of that. And then before we even get to actually deploying or anything, we need to get the business people to be excited about this. So we show our model off with a shiny demo. So after we do the exploratory analysis, we would start building a model. And our models, we ended up building neural networks using Keras. So Keras is a really, really cool R package from RStudio that lets you very easily build deep learning models. And so for us, we ended up using a convolutional neural network, which is a particular type of neural network, to do the text parsing and understand what was the topic going on in the text. But we also had to bring in all those other data types too, like what's the order status, or is their account currently suspended? And so we had more traditional neural networks parse that data. And then we put that all together with one final neural network that outputs which classification. So in this case, we would train a neural network that would learn that unlock my phone with a recent order, that has an 80% chance of being categorized as unlocked. So we built this networks, and we were pretty excited about them. But we'd have these problems because we'd go into meetings with the business people and be like, guys, look at these ROC curves. Our AOC is like 80.8. And they're like, whatever. And so we had one meeting with some business people, and 10 minutes before, we're like, let's just throw it in a Shiny demo. And this changed the game. The fact that we actually had Shiny demos where a business person could type in, I want to unlock my phone, and actually watch that would be classified as unlocked, this got us, and I'm not exaggerating, millions of dollars of funding, multiple people added to our team, and it's because we could take this, show it to a business person, who showed it to the director, who showed it to the VP, who eventually we ended up showing this stuff to the CIO, all because we had a really nice Shiny demo that we built around our models. And so if you look, this doesn't look quite like a normal, it really didn't look normal. That doesn't look like quite a normal Shiny demo, and it's because we decided to spend an extra day using, I'm going to give this a little wiggle. Let's see if that, OK. We spent an extra day making the HTML look nicer, and that really, again, gave us a really polished professional view. So I'm a data scientist, and I'm very comfortable doing all the things I just showed. But putting things in production, deployments, when I started this project, a lot of that stuff was new for me. But thankfully, our team had some machine learning engineers to help.
OK. Am I on? Hello? Can anybody hear me? There we go. OK. So when it came time to put our models in production, I was handed these R files, and I was a Java developer. And I was like, I really don't know what to do with this or how to get it in a place that can interface with our 70+ million customers. And so every single person had told our team, if you want to do machine learning in production, you have to use Python. But I was just handled a really cool R project, so I was like, hiring data scientists to redo all this work in Python and redo an analysis seems silly. Since the model's already built and it's very good and the business people really like it, I could convert it to Python and then put it in production, but that seems silly. And so I was like, what if we just do it all in R? And what if we take out this double work that people assume that you have, where you have to rewrite things for 70 million people using Python? So yeah, the radical idea here was, what if we treat R like a real programming language? Because it is a programming language. And so how things work on our team is we have all of our stuff in repositories as soon as you make a commit. And so this is the way any of our Java or Node projects would work. As soon as you make a commit to a repository, some software called Jenkins builds it up into its final project. Marathon, it's kind of like off-brand Kubernetes, orchestrates the container development in Mesos, hosts and replicates those containers for you. So we have a really nice system in place for Java projects where you could just make a commit and then instantly something's in production and it's facing with your customers. So I was like, well, let's make R do that and avoid this whole Python trip entirely. And so the first thing that we had to do is we had to convert our R models into an API. And so what an API is right now, if I was to go on my phone and type weather.com, it returns back some website for me. And that's an API. It's just a way of using the internet to send a message, I want to go to weather.com, and get some information back. Here's the entire website. That's weather.com. You can also use it with model input and output. So we want you to predict how long this stem length is, send it to the model via an API, and then it comes back, OK, I have a prediction for you. So it's very, very easy. So once you have a REST controller, which defines all the little slashes that you would put on your website URL, you just start Plumber on your R model, and then now you can go into your browser and type in something and immediately get information from our model back despite not being close to it, which is really cool. And that's how all of our services talk to each other in engineering, is via API calls. So this way we can have Java talking to Python, talking to R, and it all makes sense because it all uses the internet. And then the way that we package everything up on our team is with containers. And so what containers are is, if I was to go to Best Buy right now and buy a laptop, and I really wanted to put Jacqueline's model on it, I would have to go home, I would sit down, I would install, I don't know, my internet, and I would install Outlook, and then I would install RStudio, and then all of the packages needed for RStudio. And it gets quite cumbersome to set up the machine. And then, of course, I'm using a more recent version of the package than she was using, so her model still won't run, even though she emailed me and I downloaded it. And so what Docker is, essentially, is just a way to write down all of those instructions so that way they're repeatable forever. So that way, anytime a new virtual machine is spun up, a little container on it can just repeat those Docker images, and they have the exact same thing that I was looking at when I was on my laptop, or the same thing Jacqueline was looking at when she was on her laptop. So I can then take my code to someone who doesn't have R installed on their computer, and if they have Docker, it will run on their machine. And so the first problem that we actually had is I had this container. We used a Rocker base image. Rocker is a company that makes these I guess it's an organization that makes these R-based Docker images. So you can just kind of copy the work that they've done and start from there. And the first thing is, so I have R in a Docker image, and I have Jacqueline's model. But the big problem is that our Keras actually requires Python. So you have to call Python on the end. So we're like, OK, we have this Docker image that contains R. It contains RStudio. It contains our model. So OK, let's put in the actual Python that's required to make this run. So OK, we finally get Python installed. Everything should be good. But it's not, because Plumber doesn't support HTTPS. And we're a big enterprise, and so we have to have really secure connections between stuff, so HTTP was not sufficient. So inside of our Docker container, OK, we'll add an Apache 2 server that sits in the same container as our R code. And all it does is take HTTPS requests, converts them to HTTP, does the model processing, and then passes it back through. So OK, so now we have R, and we have the model, and we have Python, and we have this Apache 2 server, and so it's getting quite hefty. And that was actually the next trouble that we ran into. We went and we deployed it. It went through our Python. It went out perfect. But it was nearly 5 gigs in size by the time that you get all the dependencies and everything that you need. And so this is a quick breakdown of what our container actually looked like. So if you look, the bulk of the container ends up being Python. And our DevOps team was like, you guys can't keep running 5-gig containers. You've taken down entire T-Mobile clusters. Like, huge problems are occurring because you're throwing this out there. So we said, OK, we'll do some work. And so we switched the full version of Anaconda Python, which is what TensorFlow requires, to Miniconda. We removed RStudio from the Docker image, and then we spent a lot of time removing all these unnecessary Linux and R and Python libraries to get the container size small enough that DevOps would say, OK, we're totally fine with you using R now because you've made it small enough. It contains all of our security requirements. It contains everything it needs to run. It looks good to go. And we did it. So we deployed a model in R, T-Mobile's first customer-facing deep learning model, and it was all completely written in R. So it's an R-native API. It has TensorFlow. It's super, super small, and it's just as secure as everybody wants it to be and is required. So really cool. But we learned a lot of stuff in doing this. And so I think that the first thing that we learned is, people came to us in the beginning and said, you have to write this in Python. We won't support you doing it in R. But we tested our APIs at 50 times T-Mobile's maximum load, and R performed just fine. So for us, using R and Plumber was at very close parity performance-wise with Python and Flask. And then R was really good for us to do the quick data exploration that got us the idea to build this model in the first place. And then the Shiny demos are what really, really sold our project. And there's not really an equivalent for Python. You can't just quickly throw a few lines of code and take it to a business person and have it passed around like that. And most importantly, language was never the fail point for our project. It was always security concerns, or the container being too big, or Python being giant, or some dependency projects, but it was never R that was the reason that we were struggling at any point. And the next thing we learned is that it's really, really critical to work in a flat team. So traditionally how this works is data scientists, they build the model, and they'll send it over to the engineers. The engineers rewrite it in Python, they make it into something else, and then they'll deliver it to the business. But the business wants it a little bit different, so it goes back to the data scientist. And we stopped that chain of telephone, and we're like, what if we all just sit together? So our team was literally 2 machine learning engineers, 3 data scientists, a Java engineer, and then our business person all together at the same table every single day. So that way, if the machine learning engineers can be developing the API, and then the data scientists find something new they want to do, and you can just talk to each other instead of waiting 2 months until you get a finished product and then trying to iterate on that. So it made it a very, very, very agile structure.
So with all that work, it was a lot of work. We were very excited about it. Fun work. Where are we today? Well, first off,
your mic's not on.
Oh. Yeah. OK, cool. Great. The first thing is, we have R in production right now in a way that any iPhone user in the audience right now, you guys can hit R code, make R code run. which is, I don't know, I never thought there'd be that day. Never mind, I was part of that day. So in particular, there's a product called Apple Business Chat. So about a year ago, Apple released this way for companies to actually use iMessage. So if you search for T-Mobile on your iPhone, you can start a chat with T-Mobile, and it's like a nicely colored branded box. But T-Mobile doesn't get to know your telephone number. All they know is that you're an anonymous person. And so the first thing T-Mobile used to do was ask you, hey, are you a customer or not? Because they needed to know if they wanted to route you to customer care or sales. And so we'd ask the customer and get a yes or no back. And to us, this was ridiculous, right? If someone says, why is my bill so high? Of course they should go to customer. If someone says, I want to switch to T-Mobile, they should not go to customer. And so we built a machine learning model around that. And so now every time someone in iMessage starts a new conversation, it sends it to the R machine learning model. If the R machine learning model is confident they're a customer or confident they're not, then they don't see this picker at all. If we kind of get unsure, if they just say hi, then they would still get the picker like old. So we've actually used machine learning and AI to make the customer experience more streamlined rather than to do an annoying chatbot kind of like, please say unlock. So we're really proud of that. And also, you can have some of this work too. So we took a lot of what we've done and we really packaged it up and made it open source. So we've written several blog posts on how to get started with Plumber, Docker, and our actual code. And then we created a repository that is a full Docker container that uses R running a TensorFlow neural network that you can install Windows R, you can download this and run it, and it just works. The neural network we used as our sample data generates pet names, so it's a lot of fun. I recommend you trying it out. But this is really something that, if you're interested in how to work, I highly encourage you just to look at it, because, you may learn a couple things that might make it easier, and things that we had to learn ourselves over a lot of time. So thank you so much. The materials from this are all located at nolisllc.com/rstudio19, the blog post, the GitHub repository, these slides. So that's really useful. Our Twitter handles are up there. We love being tweeted at. And thank you so much. And I'd like to also just thank, Heather and I are here. James Ellison, our product person, is in the audience. And we are so many other T-Mobile people who really helped with this project, too. So we like to do a lot of talking, but it was not just us who did this project.
And also, we could talk about this literally all day. We were like, how can we condense it down into just 20 minutes? And then also, we are hiring. So if you think that what we're doing sounds really cool, we need really good data scientists. We prefer our users, obviously. And so this seems like a really great place to kind of announce that. And you can hit us up on Twitter or whatever you feel like. So. Yeah, that's why I like speaking.
Great. Thank you, Heather and Jacqueline. We've got time for a couple of questions. I think we have some microphones we can toss around on that in the back. So yeah, it looks like we've got some people. So if you have questions, raise your hand. I'll try to point those out so that we can have a microphone. Right over this way.
There we go. Hi, hello, okay. I was just curious, so you said you showed business people Shiny apps to demo your model. Do you have like an area where you just deploy those kind of Shiny apps for projects?
Yeah, so our Shiny projects actually go through the same pipeline that I just showed you. And so we have one single container right now that contains all of our different Shiny apps, and we have it up so that way anytime that James needs to go take this to a business person and show something that we built off, the link is up and always ready for him to do that.
Yeah, I would say we are going to switch to having a Docker container that has each app in it separately, because we've run into trouble where like we've updated one app and it's broken other. So yeah. Going forward, we're switching to one container for each.
But yeah.
Is that me?
Got one over there?
Yep. Because this specific instance is a Keras model, that isn't necessarily specific to R or Python. Do you need R or Python at all? Is it because of like the API wrapper or text preprocessing?
So I think that from my perspective, it was that I was handed a model in R. Why would I rebuild that, right? Like it already exists. And so the exploration was done in R, and so that's why we decided to support R natively.
Yeah, and so in particular, like with us, we first take the conversation, and then we remove the weird characters, and then we do this, and then we feed it to the model. And some of our engineers are like, wow, we could technically run TensorFlow in Java, but then we'd have to figure out what to do with all those steps, and it's like, well, we'd have to keep them in R anyway, so
And so yeah, so I think that normally the argument that people put forth is like, oh, well, it's more scalable and we support Java. And it's like, we just used all the Java tools that exist and did it in R, and it worked just fine. And then you eliminate the double work.
Okay, I have a question for your neural network. So based on the application, looks to me it's like a natural language processing. So it should be the sequence model, but you mentioned about the convolutionary neural network. Can you give me some explanation here?
Yeah, so we actually started with a recurrent neural network, and we found that the recurrent neural network did not perform as well as a convolutional neural network. Our suspicion is because of the classification. Usually someone says, Bill, so high. And like those 3 words, it doesn't matter what's all around it. So that's our suspicion for why a convolutional neural network works slightly better. But we were actually surprised at how shallow the optimal networks ended up being. Like we were expected to have like 5 layers and recurrence, but it's like 1 convolutional layer, 1 or 2 dense layers, and then that's the whole network.
You spoke about making your app secure. Can you speak a bit about that, like 2-factor authentication and like how you're able to achieve that using R?
Yeah, so all of our stuff right now is accessed from within our network, so we don't have to do an Apogee authentication, but if we did an Apogee authentication, it would be very simple. We would just make the relative API calls. One thing that we did do is that all of our messages have to be passed encrypted, and so we used there's a library that's Sodium that's really good in encryption, and then you can decrypt in Java. So we were being passed things from Java that we then had to decrypt and then re-encrypt in R, and so we use that all using the Sodium library to do that, which is AES 256 encryption, so it's pretty secure.